Hello everybody, I'd like to welcome you to this video titled Evaluating Expressions, and the goal for this video is for you to understand how you can use the order of operations to evaluate algebraic expressions and just looking at algebraic expressions and then evaluating them as well. So you will need to get out your Go Math book and turn to page 269, get out your math journal and also a pencil. So here at the beginning, it's important to understand that an algebraic expression contains one or more variables. We looked at this in the previous video. So you can substitute a number for that variable and then find the value of the expression. This is called evaluating the expression. So in other words, if I'm doing 4v plus 4, I should say, okay, I cannot necessarily evaluate this expression because I don't know the value of v. However, if I know the value of v equals 3, then I can plug in that value for v and add 4 to it, and then we get our answer 7. This is called evaluating the expression. So let's take a look at some of these problems, and you can see that these problems are on page 270 in your Go Math book. I would like you to turn there as well. So what we have is 4x, and if you remember from the previous video that whenever you have a constant next to a variable, that means multiplication. So we have 4 times x. Now here they're telling us that x equals 8, okay? X doesn't always equal 8, it's just what they're telling us for this problem. So that means we set it up 4 times 8, and that's going to give us 32. So we can evaluate this expression since we have the value of that variable. So let's take a look at the next one. So we have 6 and 5/10 minus n. So what we do, we know that n equals 1.8. So we take 6 and 5/10, and I want you to do this with me together in your Go Math book. So 6 and 5/10 minus 1/8. Why do we have 1/8 substitute for n? Because it says n equals 1 and 8/10. I think I said 1/8. It should be 1 and 8/10. And that's going to give us 4 and 7/10. Let's take a look at the next one. And remember, with these algebraic expressions, whenever it's written in fraction form, that means it's division. So what we have here is m divided by 6. What's the value of m? 18. How do we know that? It's telling us right here. So we take 18 divided by 6, and that's going to give you 3. Now let's look at evaluating expressions with the idea of order of operations. So we talked about order of operations in Module 9, and we know that we have please excuse my dear Aunt Sally. Remember, we have parentheses first, exponents, multiplication or division, whichever one comes first in order from left to right, addition or subtraction, whichever one comes first in order from left to right. All right, so for these, we have evaluated expression, n equals 5. So what we do, we're just going to rewrite this. So we have 3 times, so n is going to equal 5, so I'm going to have 5 plus 1. Okay, now I'll solve this problem here. And whenever we have parentheses next to a number like this, that means it's multiplication. All right, so the first thing I'm going to do, 5 plus 1, that's going to give me 6. And now I have 3 times 6, and that's going to give me 18 for my first one here. Again, where am I getting my value for n? It's telling me right up here. It's not always going to be this easy, but this is a pretty good first step into evaluating these expressions. Okay, so the next one, we have 4 times n minus 4 plus 14. So we're going to substitute the n for the 5 for n. So now we have 4 times 5 minus 4 plus 14. All right, first step, 5 minus 4 is 1. Not too difficult. Now we have 4 times 1 plus 14. Okay, think about order of operations. We're going to do multiplication next. 4 times 1 is 4. And again, you want to rewrite every step. I should say write every step down. And then 4 plus 14 gives us 18 for the answer there. All right, the next one, number 6. Let's do this together. So we have n equals 5, remember? So we're going to have 6 times 5. Remember, whenever the constant's next to a variable without any operation, it's understood to be multiplication. 5 to the power of 2. So when we think about PEMDAS, parentheses, don't have any. Exponents we do. 5 to the power of 2 is 25. And then we have 6 times 5 plus 25. Next step, 6 times 5 is 30 plus 25. You can see the importance of writing down each step. And now we have 30 plus 25. That's going to give me 55 for my answer. Okay, so that's evaluating each expression whenever n equals 5. Again, you won't always be given the value of the variable every time this easily, but again, it's a pretty good starter for everybody. So now what we have here for 7, 8, and 9, and I would like you to work on this with me. So we have a value for A, B, and C up here. Every A equals 3, B equals 4, and C equals 6. So let's take a look at this together and we will set this up. So the first thing you want to do is just plug in all the numbers for your variables. So we have A is 3. So since it's AB, that means multiplication. 3 times 4 minus 6. Again, once you have everything set up, not too difficult at all to work through. We still do the order of operations. So multiplication will come first. We have 12 minus 6, because we did 3 times 4, that gave us 12. And then 12 minus 6 there will give us 6 for our final answer for number 7. Okay, the next step, or the next problem I should say, we want to set it up, B and C. So we have B is 4, C is 6. So that's multiplication because two variables are next to each other without any operation here. That means it's going to be multiplication. So B is 4, and we got to plug in that multiplication sign. C is 6 plus 5. Constants next to a variable without any operation sign, so it's going to be multiplication. Okay, so now that we have everything written out, we need to think about order of operations. We do multiplication first. 4 times 6 is 24. And we have plus 5 times 3. Next step, we're going to multiply 5 times 3. That gives us 15. So now we have 24 plus 15. Final step, adding 24 and 15, that gives us 39. If you remember from Module 9, it's talking about how whenever you're doing order of operations, you should have your work look like a piece of pizza, just like that. Means we're writing every single step down here. So the answer of 39. Okay, one last one we'll do together here. A to the power of 3 minus B plus C. Okay, so we have, it's going to be 3 to the power of 3 minus 4 plus 6. Okay, first step, we're going to do parentheses. 4 and 6 is 10. So now we have 3 to the power of 3 minus 10. Next step, 3 to the power of 3. Remember, that means 3 times 3 times 3. Don't think that means 3 times 3 is 9. It means you're multiplying 3 by itself 3 times. So that's going to give us 27 minus 10. The answer of 17 for the final answer there. So you'll write 17 for number 9 there in your book. Now what we're going to do is we're going to take a look at what this looks like in a real world setting. So what we have here, this math problem is right in your Go Math book. Okay, and you can see it right on page 271. So it says the expression 6 times x to the power 2 gives the surface area of a cube, and the expression x to the power 3 gives the volume of a cube, where x is the length of one side of the cube. Find the surface area and the volume of a cube with a side length of 2 meters. So what we have here, remember the x gives us the length. All right, so because of that, what we have for first one here, we have 6 times, do it this way, be a little tricky here. So 6 times the x is going to be 2 to the power of 2. All right, so that's going to give us the surface area here. And then we do 2 to the power of 2 is 4. 6 stays the same. 6 times 4 is 24. Okay, so the surface area there would be 24 meters squared. Now for the volume, we can see the formula. It has x to the power of 3. Again, we know the length of x, which is 2 meters. All right, so that means it's going to be 2 to the power of 3. So x to the power of 3, with 2 being substitute for the variable, it's going to be 2 to the power of 3, which means 2 times 2 times 2. And that's going to give me 8 meters cubed there. So that's what this would look like in a real world setting if you're taking a look at an algebraic expression, trying to evaluate it with the given variable there. Given number for the variable, I should say. So let's take a look at one more. It says the expression 60 times m gives the number of seconds in minutes, m standing for minutes. And they're asking how many seconds are there in 7 minutes. So again, we have been given the amount of minutes, 7 minutes. Okay, so because of that, we can take 60 m. We know that m equals 7. Why do we know m equals 7? Because it's shown right here in the problem. Okay, so we take 60 times n, which is going to be 60 times 7 now. We do 6 times 7 is 442. We can add our 0 for 420 seconds in 7 minutes. So this concludes the video on evaluating expressions. If you have any questions about this concept, please come and see me.